Okay, class. Today we're going to talk about parallel and perpendicular lines, and hopefully at the end of this lesson you'll be able to recognize and be able to identify when an equation contains parallel lines versus those that are perpendicular lines. Okay. Now, before we dive into it, I wanted to review and make sure that you understand some of the components of a particular equation. So let's go ahead and start with a slope-intercept equation, such as the following. So we have an equation y equals 2x plus 3, and that is in the form of y equals mx plus b. So that is your slope-intercept form. In this equation, the slope is 2. Okay? So it's important to recognize that the slope is just before the letter x in the slope-intercept form. And then in the point-slope form, let's take a look at that example. We have the following example. Y minus 3 is equal to 2 times the quantity x minus 4. And again, the slope here is 2, as identified by the arrow. And the location of the slope is always just before the open parentheses in the point-slope form. Okay, so in both of those forms, we now know, or should know, where the slope is identified. And the reason that I am emphasizing where the slope is because that is where the indicator will be for parallel lines and perpendicular lines. Okay, so let's use examples to demonstrate what I mean by that. Okay, so in this example, we have two equations. Okay, the first is a y equals 2x plus 3. That's one equation of a line, and this is in slope-intercept form. And then we have another equation, y equals 2x minus 3. Okay, and when we're looking at whether two lines are parallel or perpendicular, the y-intercept, which is represented by 3 here and by negative 3 here, is irrelevant, meaning it doesn't matter what those values are. What we're looking for is the number before the x, okay? In other words, the slope. So in both cases, the slope is 2 and the slope is 2. And when they are identical, it means that the lines are parallel. Okay? So both those equations are parallel lines. Now, with perpendicular lines, it's a little different, but we're still looking at the slope. Okay? It's a comparison of the slope. With perpendicular lines, the slopes are negative reciprocal. Okay? Negative reciprocal. What do I mean by that? Let's use an example to demonstrate that. Okay, so we have two equations, y equals 2x plus 3 again, but this time we have another equation, y equals negative 1/2 x minus 3. And when you look at the slope, 2, in this first equation, and compare that to this negative 1/2 x, okay, we see that this negative 1/2 is actually the negative reciprocal of 2. Negative reciprocal of 2. So let me demonstrate what that means off to the side here. So if we have 2 as a slope, okay, that's really 2 over 1. Okay, it's the same thing. Now if you flip that around, meaning that if we move the 1 to the top, we move the 2 to the bottom, okay, what we get is 1 over 2. That's called a reciprocal, when you flip the numbers around, okay? And then we put a negative in front of it, and now that becomes a negative reciprocal. Okay? Negative reciprocal. So when you see that association or relationship between the slopes, which we have here, right? So we have the 2 and the negative 1/2, so that's a negative reciprocal. When that happens, we have perpendicular lines. Okay? Perpendicular lines. So parallel lines, again, are when the slopes are the same, okay, and the slope is identified by the number before the x, so those two numbers are the same, so they are parallel lines. When the slopes are negative reciprocal of each other, then they are perpendicular lines, okay? So let's go ahead and take a look at a couple more examples just so you understand what they are. Okay, here we've got 4 examples, so let's take a look at the first set, okay? Y equals 3x plus 1, and then the other equation is y equals 3x minus 5. If we take a look at the slope here, we have a 3 and a 3, okay? Since they're both the same, they should be parallel lines. Okay, next example, y equals 2x plus 3, y equals 2x minus 1. We take a look at the slope. This is a 2, this is a 2. They're both equal, so they also are parallel lines. Okay, third example. We have a y equals negative 1/4 x plus 3 and y equals 4x minus 2. Okay, negative 1/4, if we take the reciprocal of that, becomes 4, and then negate that, so now it's a positive, okay, and this is what we have here in the second equation, and so the relationship between these slopes are negative reciprocals, and so both these lines are perpendicular lines. Okay, and the last example, we have y equals negative x plus 7 and y equals x minus 6. Let's take a look at the slopes here. This is a negative 1. This is a positive 1 in front of the x, right, because it's implied and not written. The negative reciprocal of negative 1 is just 1, right? So let's write that out. Negative reciprocal of negative 1. So we have negative 1 over 1. If we were to flip those around, okay, then we get 1 over 1. It's the same thing, and we're going to negate the negative, so now we just have a positive. Okay, so no negative sign in front of it. And 1 over 1 is the same thing as just 1. Okay, that is the reciprocal, the coefficient or the number before the x, okay, 1, and therefore it is a negative reciprocal, and therefore that is also a perpendicular line. Okay, all right, so hopefully that made sense. Hopefully that was straightforward and very clear. If any of this was a little bit confusing, or if you just need to go over this again, feel free to start at the beginning of this recording again. Thank you.